also she's trying to welcome you to 5.5 continuing, and she's going back. No! Just
Well, that's a little bit of my life right there.
ow,
Let's
ow.
let's go and get started on 5.5. What do you say? So, section 5.5. We're going to be working on the last part of this section, which was centered around finding roots that were rational roots, looking at the first possible rational roots, then plugging them into the function to find the actual rational roots. But there's two other types of roots that we need to work with. One is imaginary and the other one is irrational. The nice thing about imaginary and irrational numbers is that they always come in pairs. So as you can see here, all roots have an imaginary number, such as 2i, always has its conjugate, negative 2i. So these two would be paired up like this, plus or minus 2i. The other type of conjugates that we get with this this root theorem is the irrational, would be, for example, radical 5 and negative radical 5, and that can be written as plus or minus radical 5. And here are some other examples to refresh your brain cells about what conjugates are. 3 plus 7, or plus radical 7, would be 3 minus radical 7. 4 minus 3i, its conjugate would be 4 plus 3i. And negative 9i would be 9i right here. Same thing with the radical 2 and the negative radical 2. Remember, with conjugates, you only change the operation, not the sign. So, for example, if I had negative 5 plus 3i, the conjugate would be negative 5 minus 3i. Those two would be conjugates. So we wouldn't change the sign for the negative 5, but we would change the operation here and here. So let's take a look at an example here. It says a cubic polynomial has real coefficients. What you really need to know is that it's a typical polynomial. So when you see this p of x has real coefficients, don't panic. It just means that it's a typical polynomial. So if 3 minus 2i and 5 halves are two roots of the polynomial, in other words, when you plug these two in, it's going to spit out a 0. What is an additional root? Well, we've got to find 3 because this is a cubic. So I've already have 5 halves, and the other one is 3. Whoops. The other one is 3 minus 2i. And so now use what we just learned. All imaginary numbers come in pairs. So that means we get the other conjugate for free. And we have found all three of our roots. Let's take a look at a multiple choice question here using conjugates to construct a polynomial. In other words, we're probably going to be going from zeros to factors to polynomials. You don't have to write this question down, but we do have to solve this. So it says, what third degree polynomial function, in other words, we're going to find three solutions here, has the roots of negative 4 and 2i? Well, if we get negative 4 and we get 2i, but remember, we get the third one. If this is imaginary, we know what the other one's going to be. It's going to be negative 2i. So we've got negative 4 and plus or minus 2i. These are the zeros, or roots. So if we're going to find out the polynomial, we have to go from zeros to factors to polynomials. And that's exactly how they solved this one. They said since 2i and negative 2i, they also said that negative 2i is going to be the other root. And they've set it up in factored form. Now you get the joyous task of multiplying these three factors together to get your polynomial down here. So if you recall, when you multiply 2i and negative 2i like this, if you remember Miss Carmine, she went ahead and showed you how to do this. This is going to be the factored form of x squared plus 4. Remember when you multiplied the 2i and the negative 2i, they're going to cancel out to x squared plus 4. So now that we've multiplied these two together, we now have the x plus 4 to multiply through, and that's just a distributive property. We're going to multiply x squared times all this. So x squared times x is x cubed, x squared times 4 is 4x squared, and then 4x, and then 16. And we've written our polynomial from the factors from the roots. So let's take a look at another one. We want to go ahead and write a quartic polynomial from these roots. Quartic means 4 solutions. So I've got 1, 2, 3, but remember again the conjugate rule that when you have an imaginary or an irrational, you get the conjugate for free. So I really have 2 minus 3i, 2 plus 3i, and 8, and 2. Again, those are the zeros or the roots, whichever way you want to call it. Now we need to go to the factors. So let's go ahead and write these as factors. You're going to have, let's do the 8 and 2 first. X minus 8, x minus 2. And if you think about it, we're always subtracting these things. So let's go ahead and write our next one, x minus this, and x minus this. Now we get the joyous task of multiplying these all together. So let's go ahead and multiply these two together. X minus 8 times x minus 2. Again, we have to start thinking a little bit faster. That's going to be x squared minus 10x plus 16 times these two being multiplied together. This is a little bit of a marathon right here, so you're going to have to be patient and just multiply x through all this, negative 2 through all this, and then 3i through all this. So let's do that. X times all this right here. Negative 2 times all this. And then 3i times all this. I'm going to have to erase that there. Let's see, that's going to be negative 9i squared. It's a lot, but it's not hard. It's just a lot of it. So let's keep our polynomial here. Whoops. And start combining some like terms. X squared, can't combine anything there. Negative 2x and negative 2x, that combines to negative 4x. So the x squared is taken care of, and the negative 2x's. 3xi and positive 3xi cancel out. Negative 6i and 6i cancel out. So now you're left with 4 This is negative 1 times negative 9 is going to be plus 9. So 4 plus 9 is going to be 13. Now we still need to go ahead and multiply all these together. So bear with me. It's a long, long trip. X squared times all this. Negative 10x times all this. And then 16 times all this. Let's see, 4 times 16, that's 40, and 24, so that's going to look like 64 x. And then 16 times 10 is 160. 3 times 16 is 48, so it's going to be 160 plus 48. I think that's 208. Now combine like terms, nothing but the x to the fourth. X cubed, combine those two. X squared and x squared and x squared, so it's 13 plus 40 is 53, plus 16 is going to be 69. So those are taken care of. And then negative 130 minus another 64. Plus the 208. That is a lot. Trust me, I know. It is a lot of work. But it's not hard, it's just a lot of it. I keep telling you that using that expression, but this is really, like I said, a marathon, because we need to not only do these simple tasks, but we need to do them repetitively. Not very exciting, but repetitively to get these polynomials here. By the way, our degree is 4, and we have 1, 2, 3, 4 factors and 4 roots to deal with. Well, this is again a long process, and I want you to go ahead and think about finding all the possible rational roots, all the actual rational roots, all the irrational roots, and all the imaginary roots with your conjugate theorem. This is a lot. We're going to have one practice problem during class tomorrow, and then I expect you guys to be able to take off on your own. I'll see you guys tomorrow morning.